Hello and welcome to the part B of the module 6. The title of this lecture is Natural Language Processing through Machine Learning. In this particular lecture, we are going to introduce the language AI. Then we try to understand different language representation, namely bag of words, word to vec, attention, etc. And then we try to understand how the recurrent neural network is used to model the context in a different text. Then we introduce transformer for modeling the context using attention. Then different transformer models like encoder only model, encoder decoder model, decoder only model been discussed. Then a very naive or a brief overview of the language model being discussed. And we conclude this lecture by giving a history of machine learning or deep learning models for this NLP tasks. We start this lecture by defining the language AI. So language AI, often it is called language models or natural language for AI. So is defined as this is an artificial intelligence system or kind of AI based system that is used to understand, generate and interact with human language. So it's basically AI models. That means some machine learning or deep learning based models that can interpret this language, human language, like English, Hindi, Spanish, etc. So if we have to understand that what the language AI can do, so it can understand text. What do you mean by understanding? That it can analyze or interpret the meaning of the text, intent, the sentiment or the context of the text. Okay. So it is not only just a word by word meaning, it also tried to find out some abstract concept like sentiment, context of a particular text. Now it is another capability of generating text. It can write emails, it can write articles, code, stories, even summaries kind of thing. So it is a kind of generative AI models that can generate this kind of textual representations. Thirdly, it can translate language. It is machine translation. So English to Hindi, Hindi to Bengali, or English to Spanish, Spanish to French, and something like that. It also helps to answer questions and act like a tutor. So it has a capability of explaining concept, help with the learning, and some of assistance in work. That means it helps customer support, searching capabilities, or data analysis, documentation, etc. So what we have to understand that the basic intent or basic goal of this course to understand that the ML models or deep learning models, that how these models are going to implement the language tasks. So how it works means basically these are the ML or DL models which are trained in a recent days. These models are very large model. We in some next lecture will say it's a large language models. So it's a very large model and it's trained on a large amount of text data. Okay. a huge amount of text data, and then it's fine tuned for specific applications. Okay, so they learns the context, pattern, sentiment rather than the fixed rules. So what is important to understand, these large language models, which are basically based on these transformer architecture or deep neural network architecture, they can learn a very abstract concept, a very complex concept for this natural language, like context, pattern, sentiment, etc. So it's a very powerful tool of analyzing, understanding, generating, translating the natural languages. Okay. Now, first we have to understand that what we mean by language representation. That means, given a text, how can we represent it? In image, we have seen that an image can be represented as a matrix of pixels. Now, how the text is being represented? So first of all, we have to understand the bag of words. We tokenize a text to get a just, you can say, some sort of vocabulary of the words. Okay. Then we'll see word to vec model, how word are translated to a corresponding vector, and how neural net is basically going to train to act as this kind of language representation. Then we'll see the attention, that how attention used to for the context modeling kind of thing. So one by one we understand, and the corresponding the DL models will try to briefly introduce. Okay. So first we'll start with bag of words. What does this mean? Now what it represents, as we said, it's unstructured text. Just for example, there is a two sentence, it is there. Now there is some common word in these two sentences. So India is a great country, and if you tokenize it to splitting in a word, one of the very common way to tokenizing, that splitting the sentence by using a white space. So you can say this white space, this and this. So India is a great country. So these are the words. Okay. And this sentence, it's a big country. So these also, it is a big, these are the words. Now if we represent these two sentences, we create the vocabulary like this. So combine all unique words. Now what are the unique? India is a great country. These all the words we taken, and then it is, this is already there, A is already there, country is already there. So it and big we take. So these are your unique words of these two sentences. And this representation we called the bag of words. Okay. One thing you can notice, that here in this representation, it is not mentioned what is the location of the word or position of the word in the sentence. It's just a collection or vocabulary of the word. Okay. So using this vocabulary, they simply count how often a word in each sentence appears. So quite literally creating a bag of words. So this is basically the concept or the representation of the bag of words. Now here we can see that this bag of words is basically a kind of representation that simply count how often a word in each sentence appears. So here this is the sentence. If you tokenize it, you can get these words, and now we can say in this vocabulary. So these are the how many words, that is big, a, eat, country, India, as we have seen here. So this is we have seen. So these are the vocabulary, and based on this vocabulary and in this sentence, now India is, sorry, is there in this sentence, so this is 1. Big is not there, 0. A is there, so 1. It is not there, 0. Country, India, great, all are there. So the vector representation of this sentence is basically this, just a hypothetical representation, or you can say hypothetical bag of words representation. So this is called bag of words. So the word2vec is basically a kind of embedding techniques. That what do we mean by embedding? Embedding are vector representation of the data attempt to capture the meaning. So word2vec is want to do that it try to learn the semantic representation of the words by training a vast amounts of textual data, like entirely the Wikipedia kind of thing. So first of all, we have to understand what do we mean by embedding, that given a word, for understanding that we say word, it may be sentence or something like that, but embedding is basically a vector representation that represent these words as a vector. Okay. Now word2vec is a such kind of embedding procedure, that what kind of vector it try to generate, that learns the semantic representation of the words. Now it uses a neural net to do so, for this understanding the semantic representation. Now what do we mean by semantic representation? That word2vec generate words embedding such a way that the words they tend to appear next in a given sentence. So they try to find out that two words which are somewhat neighbor in a given sentence. Okay. So what do we mean by neighbors, or what do we mean by neighborhood? That here you can give an example, that there is a gender kind of thing. King and queen, man, woman, or is a tense. It's walking, it's walked. Swimming, it's a swum. So these are the words by some semantic representation, or by some semantics kind of understanding, they are closely related. Okay. So they may be a very neighbor in a sentence. So how it being trained, this word2vec process or model? The training process, a pair of words are taken from the training data, and a model attempts to predict whether or not they are likely to neighbors in a sentence or not. That's a very interesting way of understanding the semantic representation of the word. Okay. Now here some other examples. So this training process, word2vec try to understand or try to learn the relationship between words and distills that information into the embedding. Okay. Just for example, another this is a kind of country and capital pair. So Spain, Madrid, Italy, Rome, Germany, Berlin, and so on. So if two words tend to have the same neighbors, their embeddings will be closer to one another, and vice versa. Okay, so this is the way, that is, they are semantically linked, and this semantics is basically kind of define the closeness of these two words in a sentence. Definitely these heuristics are kind of a understanding. Okay. Now here you can say that a matrix kind of thing. So embedding attempts to capture meaning by representing the properties of the word, the semantic properties of the word. That kind of word-to-vec representation is going to do this. For example, this kitten and pet may be bit, because kitten used as a pet, or it is a cute. So you can see that it is in a +1 -1 scale, it is very close to 1. So there is a lot of kind of closeness, you can say. So that it is written that the word kitten might score high on the properties cute. On the other hand, the room and milk is not that much closed kind of in that way. So that's why it is a very less score toward the negative side. Okay, so what we are basically trying to do, that we try to find out the semantic closeness of two words in a sentence by virtue of word-to-vec embedding. Okay. Now here also, if you do this kind of, then you can say, if we do this kind of embedding that measure the semantic similarity between two words, then this dog, puppy, kitten is somewhat clusters in a position. So these are the similar word or word with some sort of semantic closeness. So this, using various distance metrics, the mutual closeness between every two words can be observed. And mango and apple, two are fruits. Baby and child is basically a very closely related words. House and rooms is a very closely related kind. So in this figure, the projecting these embeddings into a two-dimensional representation, words with similar meaning tend to be closer. So it is kind of that we have to understand. So we basically, this embedding is measure the semantic similarity or semantic closeness kind of thing between two words. Okay. So this word-to-vec is basically this. Now we have to understand what are the different type of embeddings. Like we can see that this is the word embeddings in case of word-to-vec. It's possible the sentence embedding also possible. That used to indicate the different level of abstraction, word versus sentence, illustrated figure. So in this figure, you can say that the sentence, this is a sentence embedder, and this, when the sentence embedding, there is so sentence level embedding. Now this is a word level embedding. So after this tokenization, it is a word, and this is word-to-vec is basically this embedding system. So it is possible some other representation, the document level embedding. So bag of words, for instance, creates embedding at the document level, since it represents the entire document. But it just you can say, given a document means a set of sentences, and sentence means a set of words. So it basically going to how many this particular sentence or this particular word, how many times come in this document. Okay. So this is the kind of what this bag of words. On the other hand, this word2vec generates embedding for words only. Okay, so that is also important to different this embedding at a different level of abstraction. So word level, sentence level, document levels, and so on. Okay. Previously, what we have seen that this our word2vec model is basically going to create static and downloadable representation of the words. Now let's take an example. The two sentences are given. I'm writing a bank check and I'm sitting in a river bank. Now this word bank in two different sentences are completely different. Their meanings are different. It is a river bank or it is a financial institute bank. So what we can say that this bank word are different in the context. So here context means in this the surrounding words, or we can say how can we understand the context by checking the surrounding words. Okay, so word2vec model can distinguish these two same word, this bank word, by based on their context. That means that depending on the surrounding words of the sentence. In a very similar term, we can say in other words, it can't model the context. To model this context, we require some recurrent neural network that we'll see in the later half of this course. But here we just very brief introduction just to understand what is the context and how this kind of RNN structure is used to model this context. So let's try to understand. This is an encoder decoder structure. That is encoder, say one language in one is a sentence in one language, take this input and output in a different language. Here Hindi to English translation. So it is a, you can say it's a machine translation kind of. And this RNN take every words as a input this and create the context of this. And based on this context, decoder translate it in a target language. So this context, this is output of the encoder of the RNN and it is input to this decoder. Okay. So we are not going to discuss the internal structure of the RNN here. That we'll see later when we discuss the different deep neural architecture specifically for the sequential modeling. What is important here? RNN, by virtue of this structure, that can model the context. And if you know the context, then it is easy for the decoder to translate from this one language to. Let's try to understand how. Here, this context is basically modeling by virtue of attention. So what do we mean by attention? So attention allows the model to focus the relevant parts of the input sequence as needed. Okay, so attention selectively determines which words are most important in the given sentence. Just for example, what we are basically trying to say that मैं एक छात्र हूँ, this छात्र, this word is very much important. And I am a student, this student is important. So here this context is modeled by this attention mechanism. Okay. Here the context modeling is try to been described based on the attention through our recurrent neural network. That exactly what we have said, the word student and chhatra. These two words are very coherent. In this chhatra, that meaning of English is student. So the attention between both these students is very high. See? In the 100 scale, 0 to 100 scale is 95. But similarly, the word student and may, so this may and student is not that much. So it's lower score, relatively lower score. So this is way this kind of attention is basically using to model the context. So this attention based model, instead of passing only a context embedding. Now when we use this attention based RNN model, then all the hidden state of the inputs were passed to the decoder. So I am a student. The RNN keeps the track of the words, it mostly attend to the perform the translation. So as compared to the word fake, this architecture allows for the represent the sequential nature of the text and context in which they appear attending the entire sentence. So RNN is a sequential modeling technique, and by sequentially scan the entire sentence and try to find the attention of this sentence, it basically try to model the context. Now next thing that is very important milestone of this natural language processing or kind of context modeling is transformer. The transformer architecture we'll see later. This is a typical transformer architecture. So this is much advanced architecture, and compared to the RNN or recurrence network, transformer could be trained in parallel, and so far it is much faster. And the encoding decoding, as you can see here, it is basically stacked up to each other. So it's a kind of autoregressive structure. We are not going to details of this at this moment, because we in very details our discussion of the transformer in the later of this. So most important thing in this transformer is called self-attention. We understood what is attention. Now we are going to discuss what is self-attention. And another, this is called feed-forward connection or feed-forward neural network is given. So as a whole, this is a very naive, very brief discussion or introduction of the transformer. Most important why we put this, that it model the context by attention as well as the self-attention. Now what do we mean by this kind of attention? That we already know. The what doing attention, it allows the model to focus the most relevant part of the input sequence. So most important part, this student is important part. Now what do we mean by self-attention? Given a sentence, within the sentence, so if we give the same sentence, what are the most, you can say closely, right? Definitely I and I has a very high kind of similarity. But other than this, I am some similarity. I and student has. So this is the how the a particular word is associated, related to another word in a sentence, that is called self-attention. If it is a different sentence, then it's attention. But if it is in a particular sentence, if we calculate or measure the similarity between two words, it's called self-attention. Okay. So self-attention has a model to relate the words to each other in a sentence. So this compared to the previous method of attention. Self-attention can attend to different position within a single sentence, and thus it's very easily and accurately represent the input sequence. So it is not processing the one token at a time or one word at a time, you can say. If it's a token, it's a word for understanding. So it look the entire sequence in one go. So you can say sequence if we just for our understanding this is a sentence, entire sentence. It's just a simplistic way of understanding. So in compared to the encoder in transformer architecture, decoder has an additional layer that pays attention to the output of the encoder. That is called self-attention. Okay. Now there is a different types of transformer models. So it is maybe encoder only model. It is encoder decoder model or decoder only model. Now first of all, what is encoder only model? Here you can see here that this is the encoder only model. The basic example of this model is this BART. Okay, these are basically the conceptual diagrams. The exact models may be a bit different. So next is the encoder decoder. That what is the transformer itself? Generally transformer is basically encoder decoder both, and only this is a decoder only model. We just remove the encoder part and put this the decoder thing. So one by one just we'll see how very briefly what is the conceptual architecture and what are the corresponding model. Let us start with encoder only model. It is called BART. So it only uses the encoder part of the transformer. It only uses this encoder part and removes all the decoder entirely. So the basic architecture of this is something like that. We are not going to detail, but this is a kind of encoder. This is a BART base. That means this is, so this 12 number of encoders are basically given there. And given a sentence, it will give the contextualized word embeddings. So what is the example of this? This is called BART, bidirectional encoder representation from transformers. Now the architecture and the training procedure of the BART and the related architecture is efficient in representing the contextual. So it is for this contextual modeling. Okay. So there is basically two things of this that we will see the next slides. First of all is the pre-training, and next is fine-tuning for the particular application or particular task. So what do you mean by pre-training? That we have to first understand it. So this particular encoder only model, that is BART. For training, they use the masked language modeling. Now what do we mean by masked? There is a sentence is given. This is some word is mask and reading. And so transformer or this encoder only transformer is basically says this kind of that I love reading. Okay, so by virtue of this kind of setup, it learns. So in training process, some part of the inputs are masked, and this BART base, which is considered 12 transformer encoder, is trained to predict the mask part accurately. So this is the way it is trained. This is a bit difficult, but it make it these particular models they to accurately represent the inputs. Okay. Now essentially there is a two part. What we have said, one is pre-training. Is pre-trained with a very large data set. That's like a Wikipedia. That's the training part on the entire Wikipedia. It learns to understand the semantic and the contextual nature of the text. And then it is used when it is trained. This trained model is fine-tuned kind of of or some transformer kind of is used for this different kind of NLP task like text classification, named identity recognition, paraphrase identification, etc. So this trained model is fine-tuned, it's for specific task. So this is encoder only model. Now we go to our next kind of encoder decoder model. So this is a kind of transformer itself, the whole transformer. So both encoder and decoder blocks would revolve around attention instead of this leveraging RNN with the attention feature. So basically here it modeled the attention to kind of conceptualize or to represent this context. So basically we will see there is a two major blocks, one is self-attention and feed-forward neural network. And here also we can say this is a kind of Chatru, so I am a this, so this thing, when they try to find out what will be the this will take. So this is basically a kind of attention mechanism. So this particular word is based on this particular word. Okay, because I am a student is Chatru. So this after generating the words I am and a, the attention mechanism of the decoder is to focus the word Chatru before it generates the English translation student, and that is the major strength of this kind of. Okay. Now very briefly that what is the encoder structure. This is the encoder structure kind of, this is self-attention and feed-forward neural network. I am not going to details here, but this is the input sentence and this is the corresponding output of the encoder, and this output, this the corresponding of this sentence, this output is going to feed into the decoder part. There is a three thing max self-attention, this is encoder attention and feed-forward neural network. And then I am a, this when you are giving a this kind of thing. I mean, so this using this and with the help of this encoder output and this training kind of thing, the answer is student. So this is the more or less a very naive or very brief understanding of the encoder decoder model, etc. Now next is the decoder only model. Now this decoder only model, we are only decoder part of the transformer. So this is a 12 kind of decoder, and one this any of them decoder is there is a max self-attention and feed-forward neural network. So similar to this part, decoder only model architecture was proposed to target the generative task. So it is good for generating. Okay. So this architecture is called generative pre-trained transformer or GPT. This particular architecture is very well known now. Now we can use the ChatGPT kind of thing. So this GPT is coming from that generative pre-trained transformer. Given these two input sequence, then so it generates the next token or next word. Okay, so GPT-1 was trained on corpus of 7,000 books and a common crawl, large dataset of web pages, and building model consists of 117 million parameters. So a very huge. Each parameter is a numerical value present the model's understanding of the language. So we'll see again in very details the GPT architecture in the later on this course. So in summary, you can say what we have, that is a language AI model, is basically a language model. So language model is a statistical model which predicts the probability of the sentence or part of it. That if we give I am a good boy, this is a sentence. Probability of I am a good boy is very high. Where good am I? So you can say that there is a this same, the words are basically in a distorted way. So this probability is very less. Now you can say this language model is in general autoregressive. What does this mean? This predict the next word based on the previous words of sentence. That exactly you can here also we can say this. Depending on this. So I am a good boy. First of all, P of I, that P of am I star P of A I am, probability of good I am a boy. So these are the basic idea of auto-regressiveness. And now what is the pipeline? This AR language model to predict the next word. First we tokenize, that we understand. There's a white space we can tokenize, and this is embedding is done, giving some values, some vectors values. Then some language model, some transformer, decoder only, encoder only, or encoder decoder only, whatever. And then they're sampling it. What is the next thing? Will be more this kind of, which is more probable, and the detokenization is done because these are the basic these values, and detokenization as you can. So this is the way our language model or autoregressive language model. This also will discuss in detail. Okay. So this is the more or less history of language AI. In 2000, around bag of words came 13 what to wake, then 17 attention. Then these are the deep learning based models, transformer based models basically. This BART, GPT, GPT-2, and nowadays it is 2020 GPT-3, and Chat GPT is coming something like early 20, the later half of 2022. So, okay. So in this lecture, we have discussed this, what is language AI, and then we try to understand different language representation, namely bag of words, what to wake, that. Then very briefly just introduce the concept of context modeling, RNA, and how transformer are used for this attention for context modeling. Then different transformer models like encoder only model, encoder decoder model, decoder only models are then very briefly said what is language model, and we just conclude the lecture giving the history of Mendelian models of the. In the next lecture, we'll start the CNN, the convolution network. Thank you very much.